So the Thursday and Friday you were gone, we talked about transforming graphs. And on Thursday we talked about transforming the graphs of exponential functions. And it's really the same transformations that we talked about back in chapter 1. If you notice up here on this key concept box, it kind of gives you an example of what the translation is going to look like in exponential form. So we have our translations, which are our shifts. Your horizontal translations show up here. This is where you add or subtract a value to your x. And so what it will look like with exponential is that will show up in the exponent. If your exponent is 4 to the x minus 3, that's going to move it 3 to the right. An exponent of x plus 2 would move it 2 to the left. And just like before, vertical translation shows up where you add or subtract something to the end of the function, that k value. We have our reflections, and again, a reflection over the y-axis, or a horizontal reflection, is where you just make the x negative. If you make the whole function negative, that flips it over the x-axis, so that's a vertical reflection. And then we have our stretches and shrinks. Again, horizontal stretch or shrink is where you are multiplying just the x by a value, okay? And just remember that the stretch or shrink factor is actually the reciprocal of what you see. So when you see the x being multiplied by 2, that is actually a shrink of 1/2. Here, x divided by 2 is the same thing as 1/2 x. That would be a stretch by 2. And then your vertical stretch or shrink is where you take your whole function times a number, like taking 4 to the x times 3. That would be a stretch by 3, that would be a shrink by 1/4. And so what we worked on is just how to write those transformations out and describe what transformations we see. For example, it says describe the transformation of f represented by g. So in other words, f is your starting function, g is the new function. And then we looked at, well, what changed and how would I write that down? Well, for this first example, we started with 2 to the x as our original function. That would be like your parent function. And then the new function, g of x, actually ends up being 2 to the x minus 3 plus 1. And so we wrote down the changes that we saw. First of all, I noticed this, and that is a horizontal translation. Okay, and that would be to the right 3. We also have this plus 1 at the end, so that's a vertical translation, and that would be up 1. And those are really the only two things that happened. You really just have to describe what's different. Once you've described each thing that's different, you're finished. For example, in number 2, our starting function was y equals e to the negative x power. The new function is e to the negative x minus 5. So really, this is the only thing that changed. And so that would translate your graph down 5. And you're done. If you look at example number 3, your starting function was 0.4 to the x. Your new function is g of x equals 0.4 to the negative 2x. This and this are two separate transformations. The negative part of the exponent, that is a reflection, and that is actually a y-axis reflection. When you just make the x value negative, that is a y-axis reflection. Okay? The 2 being multiplied by the x is actually a horizontal shrink by a factor of 1/2. And so that's really what we looked at, and then you can then graph this new function, using your XY table, using -1, 0, and 1. On Friday, we talked really about the same thing, but just how these show up as a log problem. And if you look on this side in the core, and it says exponential at the top, it's supposed to say logarithmic. So you can just change that. But really, just because it's a log function, you'll notice that the transformations really show up the same way in your equation. And so again, we just practiced kind of describing the transformation we see again. And we'll just do one of these. So if you look here, if your starting function was y equals log base 2 of x, and your new function is y equals -3 log base 2 of x, again, describe what changed. The negative in front would be an x-axis reflection. because you're making your whole function negative. And then the 3 in front would be a vertical stretch by 3. All right. Now, we also practiced actually just writing what our new function would look like. For example, if you look at this first one, it says let the graph of g be a horizontal stretch by a factor of 3, followed by a translation of 2 units up of the graph f of x equals e to the negative x. Couple things. This is your starting function. We're going to write the new function. And what you want to look at is you kind of want to look for that phrase followed by, and that's where you split the problem. You have to take care of this information first and then do the second part. So for our problem, the first thing we're going to do is we're starting with e to the negative x. The first thing it asks us to do is a horizontal stretch by a factor of 3. Well, if you go back up to the top, a horizontal stretch by a factor of 3 is actually the example. That's when you're going to multiply the x by the reciprocal, or by 1/3. And so we are now at e to the negative 1/3 x. That takes care of the horizontal stretch. Then it says followed by a translation 2 units up. Well, 2 units up is just going to add 2 to the end of it. And that would be your new function, okay? For a log problem, if you look here, it says let the graph of g be a reflection in the y-axis, followed by a translation of 4 units to the left, if we start with f of x equals log of x. Okay? Well, a reflection over the y-axis is going to show up by just making your x negative. And so our first step will be to rewrite this as log of negative x, followed by 4 units to the left. Well, 4 units to the left is going to add 4 to your x, and so your final equation would be this.